All right, good morning. Arithmetic sequence. Just trying to get through these notes. Here we go. Arithmetic sequence is anytime you hear this word sequence, we're talking basically about a pattern. Okay, so we're going to start by calling this a pattern of numbers. And so, for example, you don't have to write this down, but we could have the pattern 1, 2, 3, 4, 5, 6. We would need commas in between. We could have the pattern that was something like 15, 18, 21, 24. We could have patterns that were like 1, 1, 2, 3, 5, 8, 13. And we could have patterns that were like, I don't know, 2, 4, 8, 16, and 32. Now here's 4 different patterns, and I've just come up with these mostly randomly. One of them is more interesting. Something that some of you are going to be really, really good at is just looking at a list of numbers and just coming up with the pattern right away. Something that some of you guys are going to not really care too much about and not be necessarily as good at. For this first pattern, what is the pattern? What are we doing mathematically to go from one number to the next number? We're adding 1, right? This is a plus 1. 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 And so that's an pattern where we're adding the same number every time. If you look at this next one, we're going to be adding 3, adding 3, adding 3. If you look at this third, we're going to be, some of you may have seen this before, it's a little cliche, it comes up all the time in math. This is called the Fibonacci Sequence. If it comes up in like the Da Vinci Code movie and stuff like that. You may have seen it before, but what it is you take the 2 numbers and you add them up to make what comes next. So 1 plus 1 makes 2, and then you take those 2 numbers, 1 and 2 makes 3, and then you take those 2 previous numbers and then you make 5. And then you take those 2 previous numbers and you make 8. And then you take those 2 previous numbers and you make 13. And it seems like a silly sequence, but it comes up all the time in mathematics. It comes up all the time in nature. It's a pattern that kind of builds on itself. It's hard to kind of describe as just being adding over and over again. And then we have this final sequence. Now, this final sequence is a multiply by 2 sequence, right? Times 2, times 2, times 2, times 2. And again, I'm sure so many of you feel like this is a piece of cake. And the good news is, it is easy. This is what we're doing all year. Now, when we have specifically an arithmetic sequence, sometimes it doesn't work. When we have specifically an arithmetic sequence, what that means is that we have a pattern of numbers where the same number is added every time. And so looking at these 4 patterns up here, they're all patterns, they're all sequences of numbers, but they are not all arithmetic sequences, okay? This first one is arithmetic. The second one is arithmetic. This third one is not an arithmetic sequence. This fourth one is not an arithmetic sequence, right? If we have, maybe we have a pattern like this, 1, 2, 4, 7, 11, right? And it's not as easy to identify as a pattern. But here we're going to be adding 1, we're going to be adding 2, we're going to be adding 3, we're going to be adding 4. It is an adding pattern, but we have to add the same exact number every time. So this does not count either. So here's the thing. We're talking about patterns, and we're talking about literally the simplest possible patterns are the only ones that we're talking about, where you take a single number and you add it over and over and over again. Okay? It could not be easier patterns that we're talking about. This funky Fibonacci one, nope. This multiplying one doesn't count as arithmetic. This adding the increasing, nope, doesn't count. And that common difference is the same number that you're adding every time, right? So simply put, the common difference is the number that you are adding. Now, for the most part, when it comes to these sequences, there's only one thing that really makes us nervous, okay? It is not the patterns. It is not the common difference. It's actually the way that these things can be written, the way that these questions can be written, okay? If we're going to do this first one, determine whether it's arithmetic or not. If it is, identify the common difference and give me the next three terms. So, number one, is this a pattern where we add the same thing every single time? And if that's the case, what are the next three terms that are going to come in the sequence? So, what do you think? Is this an arithmetic sequence? Yeah. And what are we adding every time? And so what is that 3 called? The common difference. Right. So the common difference is a lowercase d. Your difference is equal to 3. And so what are the 3 numbers that come next, right? We're going to add, we're going to get 20, we're going to get 23, we're going to get 26. Because we've literally just added 3 to 17, added 3 to 20, added 3 to 26. That's it. Now, what about a question like number 2? This is actually a pattern where the numbers are going down. And if we look at our definition here, this is where the same number is added every time. What do you guys think about number 2? So we're definitely not adding a number because our numbers would be going up if that was the case. So what we're actually doing here is we're actually adding a negative 7. Okay, so technically subtraction is the same thing as addition. And so technically we are allowed to include subtraction patterns into our adding patterns because we're basically just adding negative numbers. So our difference here would be negative 7. You can see that we've subtracted 7, subtracted 7, subtracted 7, subtracted 7. I mean, once you see it, it's a piece of cake. Then what comes next? You got to subtract 7 and get minus 12. You got to subtract 7 and get negative 19. You got to subtract 7 and get negative 26. Now we see number 3. It goes 1, 2, 3, 5, 8. This is that, I mean, it always comes up. They always use it as an example. This is that Fibonacci sequence where 1 plus 2 makes 3, 2 plus 3 makes 5, 3 plus 5 makes 8. Is that? No. No. This is not arithmetic. It is a sequence. I mean, it is a pattern. It is a number, but it is not an arithmetic sequence. We're talking about the simplest different sequences. Number 4, are we adding the same thing every time? What do you think the difference is, Jamiris? Negative 2. Yep. What would come next? Negative, this is boring. Negative 16, negative 18, negative 20. Easy. Now, We'll do one more. What about number 5? What do you think, David? So we're adding 5 every time? So it's a little foggy. I agree with you, Devin. You've nailed it, right? I mean, like, it looks almost good. Plus 5, that's plus 5, that's plus 5. Like this looks like an arithmetic sequence. But the 20 here kind of ruins the whole pattern, because with the 20 there, we actually need to add 10 to go from negative 20 to negative 10. And so is this adding the same thing every time? No. So this is no, not arithmetic. Now, a little strategy that you can use, okay, is that we can take second minus first, and that will tell us the difference. Okay, I mean, that will literally, if we do a number minus a number, that will tell us the difference between the numbers. So, if we go up here maybe for number 1, that would be 8 minus 5, which is 3. And we can see how, that's a way to find the difference. Now, we need to make sure that difference stays the same for the whole pattern. So you don't need to only do second minus first. You need to then either take that difference and apply it and make sure that it's still plus 10. Because right here, this would have told us that the difference was plus 10. Or you could then also check at another point, right? You could also then do third minus second. And then make sure that we get the same difference. You know what I'm saying? Because if we get two different numbers as the difference between, then our pattern is broken. Our pattern doesn't work. So anyways, you can see here, second minus first gives us positive 10. Third minus second gives us positive 5. Those are not the same. We're in trouble, not an arithmetic sequence. So here's where this gets confusing, because this is a piece of cake. We get an arithmetic sequence formula, and we get some stuff, if you look on your paper like this, it says where A1, okay? The arithmetic sequence formula is A little n, that's a subscript n, okay? So it's like the H2O, it's like that little 2, is equal to A1 plus, and then let's use a different color here, A1 plus D, parentheses, n minus 1. And so the only time that students ever do poorly on this test is when a student sees this right now and they say, you know what? I don't like this. What the heck are these A's? This is ridiculous. I quit. I don't like it. We got A's, we got N's, we got D's, too many letters. I quit. Okay. And at the end of the day, this is not going to be super difficult. Okay. We do need to talk about what are the A's. Okay. The way that this stuff works is that if we want to talk about these patterns, let's talk about this first one. Okay. This first one is a nice, easy pattern because the first term is literally a 1. And so if I say, what's the first number in the pattern, you would just say 1. Or what's the 6th number in the pattern? It would just be 6. That's very straightforward, makes a whole lot of sense. But if I say with this other one, with the second pattern, what's the 15th number in the sequence? That can be a little tricky because it's like, well, are you talking about the 15th number itself, or are you talking about the first number, the second number, the third number, the fourth number? I would have to go all the way and find the 15th number. So we get some kind of vocab, okay, and it's the word term. You've heard me use it. Term is how we're going to refer to the places in the pattern, okay? And so, for example, we could have the first term, and that is literally whatever number comes first in the pattern. Okay, so our first term would be 1. For the first pattern, it would be 15. It would be 1. It would be 2. And so we could also, have the third term, which would just be the third number that comes in the pattern, right? So that would be the 3 or the 21 or the 2 or the 8. So we need to make sure that we know term, and it's not a difficult vocab word either, right? It literally just means the first term is the number that comes first. The fifth term is the number that comes fifth. What you got?
So back to what you said about the second sequence.
Mm-hmm.
We found out the common difference.
Mm-hmm.
When you said like it's an actual 15th number.
Mm-hmm.
Couldn't we just do like 3 times 15 and add that to 15?
Right. So that's super smart. Okay. So what you're saying is if we need to figure out the 15th term and all we're doing is adding 3 a whole bunch of times, can't we just say the 15th term would be 3 times 15 and then add that up to the first term? Very interesting. Very interesting. We'll come back to that in 10 seconds. When it comes to terms, we're going to use a lowercase a followed by a number. So for example, the first term is a with a little 1. The third term is a with a little 3. We could have, just coming up the 10th term, meaning the number that comes 10th in line is just a with a little 10. And so it kind of comes back to, if you remember when we were doing the imaginary numbers cycling through where it went I, -1, -I, 1. And it was like, well, how lazy are you? Like, do we need a shortcut where we were subtracting 4 off the exponents? If you wanted to find out what the 15th term was here, you could literally just do +3, +3, +3, +3, +3, +3, +3, +3, and just keep going until you got to the 15th term, right? And for some of these questions that we're going to see later, that's a totally legitimate way to do it. You won't really have any problems. You guys will get it right every time. What this is, this little pattern here, is this is exactly what you were talking about, Jamarius. I mean, whether or not you've meant it or whether or not, this is not a formula that you guys couldn't literally make up on your own, which is what you've literally just done, okay? We've got A1, which is the first term. Oh, spelled my term wrong. And D, which is the common difference. Again, stuff we already know about. The only thing that's different from what Jamarius said and what this formula says is that we need the first number plus the difference, and it wouldn't be times 15, it would actually be times 14. Because you don't need to go 15 spots after 1, you need to go 14 spots after 1. So this is not, again, the only kids who struggle are kids who have already given up. So if you're staying with me, you're already doing better than them. We need 1 less than the term we're looking for, multiplied by the difference added to the first term, okay? So for example, number 7 is asking us, is this a pattern? And then they're going to ask us for a something, okay? And so what this is saying is, can you give me the 24th term of this pattern? So if we find the difference, we could just brute force it and keep going over and over and over again. Or we could use Jamarius' shortcut, or, it's not necessarily his shortcut, but he did come up with it, the arithmetic sequence formula, and go and find that term that we wanted. So first things first, what is the difference of this pattern? 4. Yep. And if you weren't sure, you could do the second minus the first, right? That's something that we have written up here. -1 minus the first, that's second minus first. That would be -1 plus 5, that would be 4. Okay, so if you're never sure about the difference, you can always do the second term minus the first term. Now make sure that we're going to continue doing that for all of them, right? Plus 4, plus 4, plus 4. Okay, it looks good. I'm happy with the difference. So now, what is the 24th term? It's going to be a big number for sure, right? It's going to be a big number for sure. We're starting at -5. We need to add 24 minus 1, 4s. So we're going to add a whole bunch of 4s. Our formula would be AN, which is basically the term that we want. So that would be A24 is equal to, and then it would be A1. Let me zoom up just a bit so you can see. Here we go. A1, which is going to be the first term in the sequence, which is going to be -5, plus the difference. We found out that to be 4. And then that is going to be multiplied by n minus 1. Okay, and our n is 24 for this question. So it's going to be 24 minus 1. So again, simply put, we just need 23 4s added on to the -5. And how do you want to calculate this? Sometimes you can do it in your head. Sometimes you're comfortable doing it in your head. Sometimes you're not. Let's just go to Desmos. There's a nice calculator. We can go and type in -5 plus 4 times 24 minus 1. 87. 87. Because basically, 23 times 4 is going to be about 20 times 4, which would be about 80. So we're going to add a little bit more than 80 to -5. So we're going to get 87. Again, Desmos works great for this. 87. Now, totally legitimate way you could have just added 4 over and over and over and over again until you got there. But it looks like this. -5 plus 4 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 plus 4. And I'll tell you what, the kids who do that, if 5 kids are going to do this, one of them is going to add the wrong number of 4s. Okay, so you can do this. You guys are smart enough. You'll pull it off. Just be careful and make sure that you're adding the right number of 4s. Okay, I like using the formula. So let's go back. This formula works pretty great, works pretty easy. What is our difference for number 8? Right, if you're not sure, you can do the second one minus the first one, which is -9. We're looking for the 15th term, so we want term 15, which should be the starting number minus the 9 repeated a whole bunch of times, okay? And in fact, we're going to need to repeat it 15 minus 1 times. Typing that in, I'm just going back to Desmos. I'm doing 20 minus 9, repeated 15 minus 1 times -106. And that makes sense, right? Our number is getting smaller, 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 smaller. It's going down by almost 10 every single time. -106 is totally legit. Let's just chat for 2 seconds about number 10. What would the difference be for number 10? Right. So sometimes it's easy to, the difference is 3. The difference is 4. Sometimes you might have a fraction. And if you have a fraction, that's when our rule works great, right? Second minus first is 1.5. Right? So I know a lot of the times you don't need this rule of taking the second minus the first, but it's always good to have. Okay. Then I would double check. It's still 1.5. 1.5. Okay, looks good. That's good enough. Now, sometimes we'll even get questions. Unfortunately, for some reason, This is like really weird type. I don't know even how to say this. The font is really weird for this question. If we are in an arithmetic sequence, write a rule and find A12 or term 12. So we're just going to assume this, that A1 is 3 and that A3 is negative 7. That's what it says, right? Yeah. We're just going to rock with the 3. So if this is the case, we know that it goes 3, that's our first term, comma, blank, that's our second term, comma, and then our third term is negative 7. And we need to figure out, what is our difference so that we can count all the way to 12. But we have a little bit of a annoyance that there's a missing term here. And so we don't know what it would be. So one thing we could do is we could just guess. What do you want to guess? Negative 2? Sure. So if we do subtract 2, that would be 1. And then if we do subtract 2. Oh, I gotcha. So you're saying that this should be a negative 2. So what's our difference? Negative 5. So we could do negative 5. That would be negative 2. And then minus 5 again. That would be negative 7. So this looks good, right? I mean, this has solved the pattern. You guys can tell Damaris, you're liking these patterns. Your mind's tracking it easy. Not everybody's going to be able to spot that out so quickly, right? I mean, maybe you could have just guessed minus 4. And then you would say, okay, that's negative 1. Minus 4 would be negative 5. Doesn't work, right? So sometimes you can just try guessing and you'll get it right eventually. Another thing that you can do is you can say, if I take negative 7 and I subtract 3, that's going to give us negative 10. That's the difference from here to here. But I can't jump negative 10 at a time, because if I jump negative 10, I'm already going to be at negative 7. And then if I jump negative 10 again, I'm going to be way below negative 7. So what I need to do is then take this negative 10, and I need to divide it by how many jumps I need to make, right? I need to make 1 jump. I need to make 2 jumps. So if I take this negative 10 and I divide it by 2, I'm going to get negative 5, and that is the difference that we need. So there's kind of this other method of, I'll be honest, the guessing method is a pretty good method, right? A lot of times in math, it's like, don't just guess, whatever. When it comes to sequences and series, what we're going to be talking about this week, the guessing method works pretty well. When we have this extra big gap, you can find out the difference between the big numbers on either side of the gap and then divide it into how many jumps you need to make it all work. So if we figured out that our difference is negative 5, now we're looking for A12. So we can do that. The 12th term should be the first term plus the difference, which is negative 5, times n minus 1, which would be 12 minus 1. So if we do that, that's 3 minus 5 times 12 minus 1. Going to Desmos. 3 minus 5 times 12 minus 1, negative 52. And remember, that's A12, or that is term 12. That is the 12th number in the pattern. And again, we could have just done minus 5, minus 5, minus 5, minus 5, minus 5. But the formula is really not that bad to do at all. Of course, number 12, you get kind of the same idea. This one is, I'm guessing that says A2, right? Yeah. I guess we'll just try this one. A2 is negative 17. A24 is 6. Now, another strategy that we could have to find this would be to use the formula that we have, and remember our formula looks like this, AN equals A1 plus D in minus 1, is to use the formula that we have and to plug in all these numbers and have D as a leftover number and solve for D that way, which is kind of what we were doing with our little dividing by method over here. If we decide that, A2, which is negative 17, and this is a tricky question. If we decide that the A2 is 17, we'll call this A1 for now. Okay, so we'll put a negative 17 in here. We don't know what the difference is. If we had to make A2 into 1, we need to make A24 into 23. And so then we know that A23 is equal to, and then that this should be 23 minus 1. And then we also know that A23 is 6. Now, this is way, way, way complicating everything, okay? You can still use this dividing method, but some teachers will tell you or will teach you that this is the way you want to use the formula. Now notice that D is our only variable left, and now we can solve for D to figure out what's going on. So we would have to add 17 over there. That would be 23 is equal to D times, that would be 22. And then we could divide and solve for D by itself. What's up, Jamarius? Did you get something different? Gotcha. I'm thinking that maybe this is not maybe that's a 1. Yeah, I'm thinking that I've messed up and that I've read this as a 2. I think that this is supposed to be a 1. Because I think that this is supposed, what'd you say? What did you have it as? You had it as A2 and you had it as 1? So what did I do wrong then? Minus 17, 23. 23 minus 1 should be 22. I don't know. I think the answer is 1. I'm not sure what I messed up here. This is a funky question. Which sucks. I'm recording this freaking video. I guess if we call that one. Yeah, I'm not sure. I think this one might just be saying A1. It's unfortunate. We just can't read the handwriting. Maybe we just ignore this. But using the formula to plug everything in, have only D left, is something that your teacher might teach you how to do. I'm not too keen on that, but you can do it. So, quick rehash of what we've talked about. You basically need to know an arithmetic sequence is where you add the same thing every time. That's it. And you need to know that these little a's are just talking about the term number. Okay, and so if you're looking for term 5, it'll say A with the little 5. If you're looking for, term 97, it'll be an A with the little 97. This formula is not rocket science, right? I mean, Jamaris was able to almost come up with it in his head without even really seeing it before. So at the end of the day, arithmetic sequences, we've done all these questions pretty quickly. It's really not too bad. I don't anticipate you guys having much problems with it. Up next is geometric sequences, which, as it sounds, is very, very similar, and will be done in just a second. So I guess that's it for the notes today.